So we'll leave the practical APGP for the tutorial later. Okay. Hey, come on now, we're starting. Exponential equations. Yes. All right. So with this section, there aren't any new rules. We're just going to use our rules that we did last time to solve problems where the unknown x is in the power. So for example, we want to solve this equation. 2 power x minus 1 equals 8 power minus x minus 3. So what we need to do to solve this is first change this 8 into 2 power 3. And then this is still x minus 3 up there. Okay. Next, we can use one of our rules of powers that tells us we're allowed to multiply these together. So that's 3x minus 9. And then this really is it finished nearly, because we know if I have 2 with a power equals 2 with a power, only true if these two are the same. You know, you never have something like 2 power one number is the same as 2 power a different number. They have to be the same number up the top. So we get x equals 3x minus 9. So we get 2x equals 9. And so x is 9 over 2, or 4.5. So that's x then. Yep. The second line, so this line here, yeah? Oh, I'm sorry, I wrote it down wrong. Well, let's just pretend this is my example then. So it's not 1a, but it's still a fine example. Okay. Did you write that down? Yes? You got it? Okay. Let me do another one of these, but maybe one that has a fraction in it. Yeah, like this one here, 1d. 3 power minus 2x, 3 power minus 3x equals 9. So we have 3 power minus 2x minus minus 3x, and 9 is 3 squared. So we get 3 power x equals 3 squared. Yeah, x equals 2 then. Yeah, did you write that down? Nearly. Okay, we'll go on to some more difficult ones now. So 2a is an example. 2a. 3 power 5x minus 6 equals square root 81 power 2x plus 6. So this one's a little bit tricky, but still the same ideas. So what we do on the right is we can change that 81 into 3 power 3, I think. Isn't it 3 power 3?
4.
3 power 4, sorry. 3 power 4. And this is power 2x plus 6. Okay, so here we have 3 power 5x minus 6 equals, and this we can change it into 3 power 4 power 2x plus 6, and then the square root makes power a half. All those powers multiply together, so you get 3 power 5x minus 6 equals 3 power 2, 4 multiply a half multiply 2x plus 6. So that's 3 power 2 multiply 2x plus 6. Oops. Okay, so we can expand on the top. 3 power 5x minus 6 equals 3 power 4x plus 24. 12, yes, thanks. Plus 12. Again, comparing, we know that it is only true if 5x minus 6 equals 4x plus 12. So we get x must equal 18. That's the answer at the end. Sorry, Naveed, a little bit too late. I know, but still a little bit too late. Zoom out, yeah. Okay. Okay, do you have this now? Yeah? Okay, so next now, I'll do 3C. Two power 2x plus 5, minus 2 power x plus 5 plus 8 equals 0. So this is the most difficult one we've had so far, and it's difficult actually because of the 8. If the 8 wasn't there, it wouldn't be so bad, because if the 8 wasn't here, I can just take this to the right and make it like the previous problems. So because of the 8, I have to do it a different way. So what I do here is I separate. This is 2 power 5, 2 power 2x, minus 2 power 5, 2 power x, plus 8 equals 0. So I'm using my first rule that just says if I multiply, I add the powers. If I multiply, I add the powers. So it's still the same. Now what I do is, make this 2 power x squared. Or maybe I'll just use a different colour here. Two power x squared minus 2 power 5, 2 power x plus 8 equals 0. Now if you look at this, it is actually an example of a type of equation we've done already. Can anyone see what type that is? It's quadratic. Because if you look at it, it's like this. Ax squared plus bx plus c equals 0, where big X is 2 power small x. So if you want, you can use the quadratic formula, or you could try to factorize it. It doesn't really matter. So if we were to use the quadratic formula, I get 2 power x equals minus b plus or minus the square root of b squared, so that's 2 power 5 minus becomes a plus squared, so that's 10, minus 4ac all over 2a, 2 times 2 power 5. Now you notice that all of these things are 2's, so you could change this here to 2 power 10 minus 2 squared times 2 5 times 2 3, and then this is like 2 1, so in the denominator is like 2 power 6. But that's good because you can see here these are all 2's, which means all those powers add together. So what's the total power I have there? 10, isn't it? So I have here, 2 power 10 minus 2 power 10 all over 2 power 6. So that's 0, so that's gone. So it's just 2 power 5 over 2 power 6. So what's that? 2 power minus 1 is 2 power x. Therefore, x equals minus 1.
Could you let 2 power x be so that...
Yeah, you could say like let u equal 2 power x or let y equal 2 power x. It's fine. It's just, I don't know. It's okay if you want to do that, but I don't... only do it if you feel you need to, if it helps you. Now this example I picked here, there's only one answer, but of course, with lots of these you get 2 answers. All of these questions on this worksheet, I've seen it in the exam, and I've seen it in section A and section B. If it's in section B, of course, it'll just be a small part of a bigger question. The only one that I haven't seen too much, I don't really see number 1 and 2 so much, but you see number 3 and 4 a lot. Okay, so we'll look at number 4 now. Can I scroll down? Yeah. So 2x power minus 3 over 4 equals 10x power 9 over 4. And there's a few ways to solve this. Some people like to put the x's together. Some people like to try and cancel the powers. I think the easiest thing to do would be just to put the x's together. So we have this one on the left, and then this one goes underneath. And then on the right, we have 10 over 2. So in other words, I take the 2 down here, and then that x goes down on the left. And I'm left with this. So on the left, I get x power minus 3 over 4 minus 9 over 4 equals 10 over 2, that's 5. So I get x minus 12 over 4 equals 5. So I get x power minus 3 equals 5. By the way, it's quite common in the exam to get something like a fraction here, like maybe minus 1 over 3 or whatever. So in this example, it just worked out to be minus 3.
Do you add log to this? To find x, do you add log?
No, you don't actually need log yet. So if you want to find x, what you do is on both sides, you put power minus 1 over 3. Power minus 1 over 3. Because the minuses multiply to make a plus, and then 3 multiply 1 over 3, they cancel. So you're left with the answer exactly as 5 power minus 1 over 3. Yes, if you really want to. So again, just on the side here, I'll go back to this in a moment. In the exam, it'd be typical to end up with something like this. X power 3 over 4 equals 6. So what you would have to put on each side, in this example, what would I need? Yeah, 4 over 3. Because that's what will cancel this to leave me with just x. So that's very common in the exam. It just worked out a little nicer here to get minus 3 at the end. Sometimes they ask you for the answer exactly. So if they ask for the exact answer, it's this. And sometimes they want it as decimal places. So can someone type it in on the calculator? What would this be to 3 significant figures? 0. 584. 585. 3 significant figures. Okay. Now you said, Tanish, can you use log? You can, but we won't really look at that until the next lesson. Okay. By the way, were there any questions on the, because I think our tutorial, we won't have too much time in it because of the practical questions. Is there anything people need to see on page 58 or 60? The last two. No? Yes, which one?
3y.
On which page?
60.
60. 3y. Oh, yeah, okay. Yeah, I'll do 3y now. Can I scroll down? So we have 6 log 125 25 minus 2 log 5 125. I think the best thing to do here would be swap, change this into 6 log 125 5 squared minus 2 log 5, this is 5 cubed. So that would be 12 log 125 5 minus 6 log 5 125. Sorry, no it's not. Oh,
6.
sorry.
6.
5 here. Yeah. 3 comes down, 2 comes down. Yeah. So this would be 12 over log 5 125 minus 6 log 5 5. I can see that log 5125 is 3. And then log 55 is 1. So what's that? 4 minus 6 minus 2. Yes. Same page? Are you sure? It's not working. Maybe it's not matching up with the back, is it? Okay. 4H. Log E 0.5. So on your calculator, that's ln 0.5. I need my calculator here. Matching up, I think. Yeah, it's okay. Anything else people need to see? 2 on the same page, yeah? 2n. Okay. 2n. Log x6 plus log x2. Oh yeah. Log x12. That's it? Yeah.
2n.
The next one, yeah? Oh yes. That's a good one. 2n. 21 log c cubed 3. So I would say that's 21 over log c cubed. Then you ask yourself, c to what power makes c cubed? And the answer is 3. So this would be 21 over 3. Oh, that makes it less nice. Well, I still have to do it this way, but sorry, that's a 3 and c cubed. Okay. Now with the 3, I can take it down in front. 21 over 3 log 3c. This, which is it, the fourth rule, wasn't it? This 3, or the third rule, that can come down in front. So I'll just leave it with this. And then what I used here was the rule, maybe the fourth rule, that says I can swap these, I just have to make it 1 over. So it's rule 3 and rule 4 I have to use. This will be 7 over log 3c. If I swap them back, I get 7 log c3. Yeah. I've seen all of these in the exam. Okay, do you have that taken down? Yeah. Just to remind you, I'll have a check of the homework later today in the tutorial. So if you don't have it all finished, you can try and finish it now. But what I want you to do from page 62, the last 3 from each. The last 3 from each.